Alright, in this first video we're going to go over a bit about classifying real numbers. So first, a definition. A real number is any physical quantity. These include pretty much any number you could think of, such as -5, 9, 0 is a real number, fractions are real numbers, decimals are real numbers, so something like 28.21. Really weird things like square root of 2, pi, and the cube root of -32 are also real numbers. But there are some important subsets of the real numbers. These include the natural numbers, which start with 1, 2, 3, and just keep going up. Here, this ... this is called ellipsis points. And notice for the sets, I include them in curly brackets, but the ellipsis points tell me that I just keep going, so 5, 6, 7, etc. The whole numbers are like the natural numbers, except that they include 0 as well. And the integers are just like the whole numbers, except you have all the negative natural numbers as well. ... -3, -2, -1, 0, 1, 2, 3, etc. The rational numbers are any fractions. So for instance, 1/3, which is a repeating decimal. And or it could also be terminating decimals, such as 3/4, which is 0.75. But you notice here, all rational numbers either repeat or terminate in their decimals. Irrational numbers are non-repeating, non-terminating decimals. With that said, there is a nice structure to all of these subsets. Namely, if you were to consider all of the real numbers, you would be able to sort them into the rationals and irrationals. But since, for instance, any integer, you'll notice, can be written as a rational number, just write 1 as the fraction, 1 in the denominator, you have that the integers are all rational numbers. But of course we see here that all of the whole numbers are integers, and all the natural numbers are whole numbers. So there really is a nice little structure and inclusion in all of these. Also, in light of the definition of rational numbers and irrational numbers with decimals, an alternate definition for a real number is any number with a decimal representation. Now, as far as classifying numbers goes, this chart can be really helpful. For example, considering this set of numbers, let's try to determine which numbers in this set are natural numbers, whole numbers, integers, rational numbers, and irrational numbers. Well, for the natural numbers are all the positive integers. The only positive integer we see here is 7. For the whole numbers, it's all the natural numbers, but also including 0. The integers are just like the naturals and the whole numbers, except that we also have negative natural numbers as well. So negative 13 and negative 1 also will be part of this. Now, fractions, because we could write negative 13 as negative 13 over 1, it is actually a fraction. Same with all the other integers. And so because of that, every integer is a rational number, as we mentioned before, and thus all we have to do now is throw in all the other fractions as well for the rational numbers. So we have negative 13, negative 1, negative 1/3, 0, 5/8, and 7. And now the easy part is all of those numbers in the set that aren't rational numbers must be irrational numbers. So negative square root of 5, square root of 2, and pi. Now, in case you didn't get the hang of it, here's an example you can try. So, here's an example you can try. Determine which numbers in this set are natural numbers, whole numbers, integers, rational numbers, and irrational numbers. I encourage you to pause the video at this point and try working this out. If you have it worked out, here is the answer so that you can check. And a helpful thing to note here is 6 over 3 is actually equal to 2. So it is, while it looks like a rational number, it is also, in fact, a natural number. That's also a whole number and an integer. If you would like some more practice in classifying real numbers, be sure to look at Ron Larson's Pre-Calculus with Limits, Appendix A1, Real Numbers and Their Properties, page A11, numbers 1 and 7 through 10. In our next video, we'll be talking about how to order the real numbers with inequalities and intervals.